Morning, this is Mr. Tuttle, and I'd like to talk about two kinds of normal distribution problems. Problem 1 is finding the normal probability when you know the z-score. Problem 2 is finding the z-score when you know the probability. This video will discuss problem 1, and the next video will discuss problem 2. Suppose we want to calculate the probability a standardized normal z-value is less than 1.27. In all these problems, the first thing I like to do is draw a rough normal curve with the z-values on the horizontal axis and shade in the area I'm interested in. We do this because with continuous distributions, probabilities and areas are equivalent. The probability that z is less than 1.27 equals the shaded area under the curve less than 1.27. Now how do we find this probability? You have three choices. You can use the normal table in Appendix A-2 in the back of the book. You can use Excel, or you can use StatCrunch. To do this with the normal table, first observe, and this is a portion of that normal table, that the body of the table contains 4-digit probabilities. The first column to the left contains z-values to 1 decimal place, and the top row contains the second decimal place of those z-values. So corresponding to z equals 1.27, we go down till we get to the 1.2, across till we get to the 0.07, and then where the 1.2 and the 0.7 meet, which is 0.8980, that is the probability that z is less than 1.27. And that's how you would do that with the normal table. To do this in Excel, just open Excel and type in any cell norms dist 1.27, and that will also give you 0.8980. Let's do another problem. Suppose we want the probability that z is greater than 1.27. Again, we sketch the curve, but this time the shaded area is going to be to the right of the 1.27. Now, we just calculated the probability that z is less than 1.27 is 0.8980. The probability under the entire curve is 1. So, therefore, the probability of z being greater than 1.27 is going to be 1 minus that 0.8980, which is 0.1020. And to do that in Excel, we just do 1 minus norms dist 1.27. A third problem, this one's similar to the first. Probability that z is less than negative 1.23. Again, we sketch the area we're interested in. We go down in our normal table to negative 1.2 on the first column, to 0.03 on the first row, and where the negative 1.2 and the 0.03 meet is 0.1093, and that's the probability z is less than negative 1.23. Now let's put the first and third problems together. Suppose we want the probability that z is in between negative 1.23 and 1.27. Well, we already calculated the probability that z is less than 1.27. We calculated the probability that z is less than negative 1.23. If you think about it, the difference between these two is the area we're interested in. So, using the two numbers we recently calculated, it's 0.8980 minus 1093, which is 7887. To do this in Excel, we do norms dist 1.27 minus norms dist negative 1.23. Now, how can we use StatCrunch to do these? To do this in StatCrunch, go to My Stat Lab, go to a problem that has StatCrunch as an option, click StatCrunch. Then once you get this spreadsheet type display, click Stat, click Calculators, click Normal, and you get a menu like this. We're going to leave the 0 and 1 mean and standard deviation alone, and now we have the probability x is less than or equal, and then we have a left box and we have a right box. So for the first one, we want the probability that x is less than or equal 1.27. Enter that in the left box, hit compute, and that's the same 8980 as we got before. Similarly, we could change the less than or equal to a greater than or equal to, and we could use the right box instead of the left box.